This video is going to discuss the basics of trigonometry at year 12, and they differ from year 11 in that the triangles are no longer right angle triangles. If we have no right angle, then we have no hypotenuse, we have no opposite, we have no adjacent, we need another system. And the one used is to call one side A and make the opposite angle A, where the angle is capitalized. One of the sides is B, and the opposite angle is B, and that leaves the third side to be C. In each case, the angle is capitalized and the side is small. For the purposes of NCEA trigonometry, you should make the side or angle that you are trying to find A, because that's the way the formulas work. So let's have a look at the formulas that you're given. First up is the sine rule, called that because it only has sine in it, and that relates one side to its opposite angle and another side to its opposite angle. We can flip that upside down so that the angle's on the top, and that's going to help solve it when we do some of those. We also have the cosine rule. No sine in this, only a cosine. Again, it tells us what A is in terms of the other sides and angles, and that can be rewritten in this form so that we are finding the angle in terms of the three sides. The last formula is the area of a triangle formula, and we just plug that in. That's very straightforward. So those are the formulas we're given, and we need to know how and when to use them. I'm not going to talk about how to use them, that's separate videos. I'm going to talk about how we form the triangles that we need. Because to solve a triangle needs three pieces of information. So let's look at a triangle. This one is not solvable. We have one side and one angle. We cannot find the opposite side. But you're not going to be given triangles with insufficient information, because then you couldn't do the problem. What you will be given is complicated shapes which you have to divide into triangles, and you need to know how to divide them. So look, in this quadrilateral, we could divide it this way. But if we do that, neither the top nor the bottom triangle have three pieces of information. We've got a side and a side for the bottom triangle. We've got a side for the top triangle, but we have no information about the angles. You have to be very careful at this point not to think that these angles are split in half. They aren't. Alright? You can't tell what size those two angles are. You need to have an explicit piece of information. The whole angle has to be included. So how about we divide the quadrilateral the other way? Divide the quadrilateral the other way, then we have three pieces of information for this one. We've got two sides and an angle. That means it can be solved. Then when we've solved that triangle, we will have the length needed across here to solve this triangle, because once we've solved the diagonal length, we'll have two sides and an angle. X has been split in half, and we're going to have to find x in two parts, but you don't worry about that. You just divide it so that you can solve the top, and then you divide it so that you can solve the bottom, and you worry about where you're headed later. So one good practice to get into is whenever we're asked to solve a triangle in a complicated shape, just redraw the triangle separately. Take it out, use that, and then go on to do the next one. Don't try to apply it across your complicated shape. Alright, next up, having got a triangle we know we can solve, we need to look at it and say which rule are we going to use. So we look at this, three pieces of information. Does it have a side we're given versus an angle we're given? If you can find that, we use the sine rule, otherwise we use the cosine rule. So do we have one? No, the unknown angle is opposite a known side. The known angle is an unknown side, and the other known side is an unknown angle. So we do not have a known angle versus a known side, which means we cannot use the sine rule. We have to use the cosine rule to solve this triangle. If we look at this version of the cosine rule, then we see to find the angle we need the side B, the side C, and the side A. So we need all three sides of the triangle. If we don't have all three sides, we cannot solve using that formula. We need to use this formula because this formula has two sides and one angle. So that's how we decide which formula we're going to use. And you don't worry about the fact that using this formula doesn't get you to y first. Sometimes it's going to take several steps. In this case, we use these sides and angles to find this length, and then after that we now have a side angle pair, which enables us to use the sine rule, and now we can find the value of y. So we divide our shape into triangles. If a triangle has three pieces of information, then we can solve it, and then we look and we see if we can find a known side versus a known angle, in which case we use the sine rule. If we can't, then we need to use the cosine rule. And often there's more than one step involved in the process. Finally, if you get very stuck and you haven't got enough pieces of information to solve a triangle, you need to fall back and remember your year 10 geometry. So we need a few rules of geometry before we go forward. An example is one like this. We have three pieces of information, but there's no side angle pair, so we can't use the sine rule. We can't use this version of the cosine rule because it needs two sides and the angle between them, and we only have one side. We can't use this version of the cosine rule because we need all three sides. But we're not actually stuck. Even though it doesn't seem like we can use any of the rules, we use geometry. 180 degrees in a triangle mean we can calculate the angle at the bottom. And now we have a side angle pair and we can move forward. So whenever you have a triangle and you have two angles in it, your next step immediately is to calculate the third angle. That's one of the things you just have to teach yourself to do. A couple of other rules apply as we get up into merit. That is, vertically opposite angles are equal, and angles on a line add to 180 degrees. Sometimes with more complicated shapes they all come into play. So this is the core of being able to do trig. Can you find a known angle side pair? If you can, use the side rule. If you can't, you use the cosine rule. Don't worry about that you can't solve it in one go. It's often more than one step. And don't forget your angle geometry for triangles and angles on a line.